Now the final chapter, or the final topic, within this chapter is sketching regions. So the first one we're going to sketch is the region x is less than or equal to 5. When you get a question like this, you just actually consider sketching x equals whatever's there. You change the inequality sign to an equal sign initially. Now what does y equals x take 5 look like? Well, it is a vertical line that goes through the x-axis at 5. And there it is there. Now, I needed a solid line because that said less than or equal to. When we get to these questions, we're going to get dotted lines. So remember, if you have either of those two signs, we're dealing with solid lines. If we have either of those two, we're dealing with dashed lines. Now, if I'm looking at x values that are to the left of 5, I'm looking at everything to the left of that line, and that's the region that gets shaded in, and that's my answer. Everything to the left of that vertical line, including that vertical line, has an x value that's less than or equal to 5. Let's try the next one. I'm going to graph y equals minus 2. Looks like this. There's my x-axis, there's my y-axis. There's the line y equals minus 2. It's a horizontal line going through the y-axis at minus 2. Now I'm focusing on where are the y values bigger than minus 2. Well, they're bigger than minus 2 above. So the answer is everything on that line and above. That's the region that needs to be sketched. So it's a color. This is basically coloring in. So we colour in the correct side of the line, and there's our answer. Question 3, a little bit trickier. And this is where we'll start using some test cases. But the first thing we need to do is we need to look at y is greater than or equal to 3 take x, and 2y is less than x take 2. And we need to consider the first one. We're going to sketch y equals 3 take x. Now, if you were going to sketch y equals 3 take x, how do you find an x-intercept? Well, you let y equals 0, and if you do that, you get 0 equals 3 take x plus the x to both sides, which means it's going to cross through the x-axis at 3. If I want to find the y-intercept, I'm going to let x equals 0, so y equals 3 take 0, you just get y equals 3. So I need to be careful. Look at the question. It's a solid line. So we draw in our solid line, and that is the line y equals 3 take x. Now we're going to graph the line y 2y equals x take 2. Now, how do you find an x-intercept? You let y equals 0. So if in the question I let y equals 0, I get 0 equals x take 2 plus 2 to both sides, I get x equals 2. So I can go to the x-axis at 2. To find the y-intercept, I'm going to let x equals 0, which gives me 2y equals 0 take 2. 2y equals minus 2, y equals minus 1. So go to the y-axis at minus 1. Now, when I join them, because that's a less than, it's going to be joined with a dashed line. And so that's the line 2y equals x take 2. Now, when you look at this, I've now got a region in here, I've got a region over here, one down here, and one in here. There's 4 regions. One of those regions is the correct one that I want to colour in. What I'm going to do is I'm going to take y is greater than or equal to 3 take x, and I'm going to test 0, 0, because that's the easiest point to use. As long as it's not in contact with any of the lines, I use that point. Let's say, for example, this line here went through 0, 0. I'd pick another point, 0, 1 or 1, 1 or 1, 0. I just test a point that doesn't come in contact with any line. So, what this is saying is, let every x value in your equation be replaced with 0, every y value be replaced with 0. So I get 0 is greater than or equal to 3 take 0. 0 is greater than or equal to 3 is a false statement because 0 is not bigger than 3. I'm also going to come over here and I'm going to test 0, 0 on 2y is less than x take 2. So everywhere I see x, I put in 0. Everywhere I see a y, I put in 0 because that's the point I'm testing with. So 2 lots of 0, 0 is less than 0 take away 2. 0 is less than minus 2. Well, that's false as well. So what does that actually mean? Be careful. I'm going to actually highlight something here that's not right, so just watch what I do first. For this first test, because it was false and I was testing the line that it was involving the 3 take x, that's this line, 0, 0 is on the false side of the line, so I actually want to shade the opposite side of the line. But don't copy this down yet because this is not the answer. Because by shading that, I've actually shaded this section and this section. I only want one of them. I don't know which one yet. I've got to look at this one as well. Now, I've got a false answer for this because 0 is not smaller than minus 2, which means 0, 0 is on the wrong side or the false side of my dashed line. So for the dashed line, the false side is the opposite side to 0, 0. And you can see this is where my overlap happens. So when I'm looking at this question, the green bit is the bit I need to colour in. That's the answer. And we've got our region shaded there now. Okay, so that's how it works. Now let's try another one. X squared plus y squared is less than or equal to 25. Well, the first thing we want to do is we want to consider it as being x squared plus y squared equals 25, which is a circle with a centre at 0, 0 and a radius of 5. Now, because that's less than or equal to, when I graph it, it's not dashed, it's a solid line. So I can just do a sketch that's a solid line. It's got a radius of 5. Pretty dodgy looking circle. Now, less than or equal to means inside the circle. Bigger than means outside the circle. So when I'm shading this one, I'm colouring the inside of the circle and I'm done. So there's your circle question. Now let's try a parabola question. Sketch y is greater than x squared. That's a little bit like y equals x squared. That's what we've got to consider. But because it says greater than, not greater than or equal to, when I draw it, it's got to be a dashed line. So it goes like this. So that's y equals x squared. Now, I've got a fair indication of what's going to go with this one, but I'm going to be a little bit more careful and test it. So with this one, I'm going to test a point that's not on the curve. Now I can't use 0, 0 because that works on it. So I'm going to use 0, 1. So 0, 1 is about there, I'd say. So that would be 0, 1 there. Doesn't come in contact with the parabola. So let's see if it gives a statement that's true or false. Everywhere I see x, I'm going to put in 0. Everywhere I see a y, I'm going to put in a 1. So I get 1 is bigger than 0 squared, which is 1 is bigger than 0, which is true. Well, if that statement is true, that means that point is on the side of the parabola that I want to shade in, so I'm shading inside the parabola. And there's my answer. So hopefully you get the idea. Practice, practice, practice. These ones do appear occasionally on HSC exams, so it's important you understand it.